Okay, this is an extra section for Verilog chapter. Before dealing with complex designs, I want to explain the basic concept of design complex IP blocks, such as DMA, UART, I2C. Usually, a complex block can be divided into two segments. Yes, the control segment and the data path segment. The data path segment is easy to understand. Usually, the data path segment will do the arithmetic algorithm, such as you will do the AND multiply operation at the data path segment. And for the control segment, you will control the data computing in the data segment. So you may write some file state machine or some control logic to control the data computing, such as when you will receiving input data and what type of arithmetic operation you will put on the data, and when you will output data. So this is called the control path. And for big designs, we usually use the top-down methodology to design a complex block. Compared with top-down, there is a so-called bottom-up methodology. At bottom-up, you usually design the small functions from the bottom and assembling them up to make bigger functions. While for top-down, we start from the protocol or algorithm, then we divided them into sub-modules, and then we design each sub-module. And finally, we will assemble the sub-module up to make the big function. So, for top-down methodology, you first have a view of the whole design. Then you divide the big design into many sub-blocks that you can handle and design the sub-blocks, then assembling them up. But for bottom-up, when you begin it, you don't have the whole view of the design. This is the difference. So for complex designs, we usually adapt the top-down methodology to design a mini scale of design. And Verilog is the language that gives us the ability to describe such big designs that can't be imagined by drawing schematic of logic gates. In the early age of 1980, engineers draw schematic of logic gates to design a chip. At that time, they usually design chip with logic about thousands or 10,000 scale, not as big as we done now. And when you design the hardware, you need thinking hardware. That is, you have to first think out the architecture or block diagram of the circuit, then code it or describe it in Verilog. You can't do it in the inverse way. That is, when you have the problem or when you have the requirement, you just code it in Verilog and let the tool think about the architecture for you. Or let the synthesizer tool think about the architecture for you. This is totally wrong. Okay, thanks.